In this video, we are going to be focusing on analysis of concentration measurement, mean, median, and standard deviation. In this analytical chemistry problem, concentration measurement of a compound in a sample are provided. The tasks involve calculating the statistical parameters, such as the mean, median, and standard deviation, and relative standard deviation, which is known as RSD, from the given data. When we start analytical chemistry, in analytical chemistry, this often requires the precise determination of compound concentration in sample. Statistical analysis of concentration measurement is essential for the evaluation and accuracy and reliability of experimental data. In this problem, we are provided with 10 concentration measurement in ppm. When I said ppm, this simply means part per millions of a compound in a sample. By calculating the mean, median, and standard deviation and relative standard deviation, which I also mentioned previously, I said, which is known as RSD. We aim and assess the central tendency, variability, and consistency of the measurement. These statistical parameters provide valuable insight into the quality of the analytical result and aid in the interpretation of experimental findings. Let's assume you are given this kind of problem that says in analytical chemistry experiment, a scientist measured the concentration of a compound in 10 samples and obtained the following results in ppm. So here we are given the observation. First observation is 12.3, 11.8, 12.0, 12.5, 12.2, 12.1, etc. up to 10. And we are asked to calculate the mean, median, and standard deviation, also the relative standard deviation of this measurement. How can we solve this problem? Let's write our data. In the first case, we are asked to calculate what? Mean. Second is median. Third is what? Standard deviation. The next one is relative standard deviation, which is RSD. What is the formula for us to calculate mean? When we set mean, it can be mean is denoted by x, which is going to be the summation of x divided by n, which simply means we are going to sum all the observation, total number. We are going to sum the numbers of observation and divide it by its total number. What about median? In this case, since there are 10 measurements, the median will be the average of 5th and 6th values. That is when we arrange it in ascending order. Therefore, we can set median, in this case, is going to be 12.1 plus 12.2 divided by 2. And in this case, this is simply going to be 12.3 divided by 2. Sorry, my apologies. It's 24.3 because 12 plus 12 is 24. 0.1 plus 0.2 is going to be 0.3. This is going to be 24. This is simply going to be 24.3 divided by 2. If you punch in this on your calculator, the median is going to be 12.15 ppm. So in this case, let's put it separately and say our median is simply 12.15 ppm. What about our mean? We have found our median. Let's find our mean. Our mean, we said, is x, which is going to be the summation of x divided by n. And remember, our number of observation here, we are given from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The first one we are given is 12.3. next is 11.8, next is 12.0, next is 12.5, next is 12.2, next is 12.1, next is 12.4, next is 11.9, next is 12.3, and the last one is 12.0. So when we are asked to arrange this in ascending order for us to find our median, we have already done that and we obtain our median to be 11.15. What about our mean? Since we are going to sum all the numbers of observation and divide by the total number, and the total number here is 10. In this case, this is simply going to be bracket, we can set 12.3 plus 11.8 plus 12.0 plus 12.5 plus 12.2 plus 12.1 plus 12.4 plus 11.9 plus 12.3 plus 12.0 divided by our total number, which is 10, right? So in this case, if you punch in your calculator, this is simply going to be 120.5. 120.5 divided by 10. 120.5 divided by 10, this is simply going to be 12.05. In this case, since our median is 12.15, our mean here is going to be 12.05, and also in ppm. Therefore, if you notice, there is difference between our mean and our median. We have found our mean, our median. We are left with standard deviation and relative standard deviation, which is RSD. How can we find our standard deviation? First thing we need to do is to calculate the mean deviation for each measurement. When we set mean deviation, let's donate it with MD, which is mean deviation. And we set for each element, this is simply going to be what? Our measurement minus our mean. In this case, the mean deviation, we can say, okay, let's just say mean deviation MD of 1, mean deviation of the first observation. This is simply going to be 12.3 minus 12.05. Since our mean is what? 12.05. We are going to subtract that 12.05 throughout our values up to 10 times. In this case, our first observation is what? 12.3 minus 12.05. Our mean deviation of the second observation is simply going to be 11.8 minus 12.05. Mean deviation of the third observation is simply going to be 12.0 minus 12.05. This is different. So our mean deviation of the fourth observation is simply going to be 12.5 minus 12.05. 12.5 minus 12.05. Our mean deviation of the fifth observation is simply going to be, of the fifth, right? It's simply going to be 12.2 minus 12.05. What about the mean deviation of the sixth observation? In this case, this is going to be 12.1 minus 12.05. Alright, the first one is going to be, if you minus this from this, this is simply going to be 0.25. Next one is going to be negative 0.25. It's going to be negative 0.25, and the third one is going to be negative 0.05. Next one is going to be 0.45, and for the fifth one, this is going to be 0.15, and we have the sixth one is going to be 0.05. Remember, we are left with 3. we are left with 4, which is mean deviation for 7, 8, 9, and 10. So we are going to say mean deviation. We are going to say the mean deviation for number 7 or 7 observation is simply going to be 12.4 minus 12.05. Mean deviation for the 8th observation is simply going to be 11.9 minus 12.05. So the mean deviation for the 9 is going to be 12.3 minus 12.05. So the mean deviation for the final 10, which is going to be 12.0 minus 12.05. So for the mean deviation of 7, if you minus, let's use another column. Mean deviation for the 7, if let's say mean deviation for 7, I'm trying to put the answer because there is no enough space for me to insert it here. For 7, this is going to be 0.35. For mean deviation for the 8, for the 8 one is simply going to be negative 0.15. Mean deviation for the 9, this is simply going to be 0.25. That is if you minus 12.3 minus 12.05. And the mean deviation, let's say mean deviation for the 10th one, this is simply going to be negative 0.05. And this is it. So next thing you need to do is to square each mean deviation. How can we do that? Let's get rid out of these values there so that we can have enough space to write. If we next, that's the first step. We have already substitute our mean deviation, which is measurement minus our mean, and we have already gotten our values there. Next thing we need to do is to square each mean deviation. The first mean deviation we have is 0.25, second is negative 0.25, third is negative 0.05. So we are going to square everything. In this case, this is going to be our mean deviation of the first observation is simply going to be 0.25 square. Mean deviation of the second observation is going to be negative 0.25 square. What about the mean deviation for the third, also in square root? This is simply going to be negative 0.05 square. What about the mean deviation for the fourth observation in square root also? This is simply going to be 0.45 square. What about the mean deviation for the fifth observation? For the fifth observation, this is going to be 0.15 square. What about the mean deviation for the sixth, also in square root? Sixth one is 0.05. 0.05 also in square root. What about the mean deviation for the second? In square root, this is going to be 0.35 in square root. What about the mean deviation for the 8th in square root? The 8th one is simply going to be negative 0.15, negative 0.15 also in square root. So next is mean deviation for the 9th. This is simply going to be, for the 9th one is 0.25 in square root also, and the last one is mean deviation for the 10th. For the 10th one, this is simply going to be a negative 0.05 also in square root. In this case, what is the square root of 0.25? This is simply going to be 0.0625. Negative 0.25, this is simply going to be negative 0.0625. Feel free to try it on your calculator, and let's provide the answer ourselves here. The 10th one, which is the last one, this is simply going to be negative 0.0025. And the 9th one, that's 9th observation, which is 0.0625. Next is negative 0.0225. What about the square root, which is MD3, square root of negative 0.05? This is simply going to be negative 0.0025. Here is going to be 0.2025. And the next one, which is 0.15 square root, is MD5. This is simply going to be 0.0225. What about the 6th one? This is simply going to be 0.0025. 7, this is simply going to be 0.1225. Now that we have found our square root, we have squared each mean deviation. Next thing we need to do is to find our variance. How can we do that? Let's get rid of everything here. Let's find our variance. So mean is given, median is given. Let's find our variance now. It's unknown. If we set variance, this is simply the sum of square root of mean deviation divided by n minus 1. Let's write it down. Sum of square of mean deviation divided by n minus 1. So variance is simply going to be this sum all the square of our mean deviation. The first one, you can say bracket of 0.0625 plus bracket of negative 0.0625 plus bracket of negative 0.0025 plus bracket of 0.2025 plus bracket of negative 0.0225 plus bracket of bracket of 0.0025 plus bracket of 0.1225 plus bracket of negative 0.0225 plus bracket of 0.0625 plus the bracket of negative 0.0025 divided by 10 minus 1. In this case, our variance, if you punch everything in your calculator, you are going to be left with 0.285 divided by 9, since 10 minus 1 is simply going to be 9. At this point, we can calculate the standard deviation because we have already found our variance, and our variance at this point is simply what? Variance is, if you divide 0.285 by 9, this is simply going to give you the value of variance to be 0.0317. That is if you round everything up. So our variance is going to be 0.0317. 0.0317. So now that we have found our median, we have found our mean, we have found our variance, we can now simply find our standard deviation. The standard deviation is given by sigma, which is what? The summation, square root into summation of xi minus x bar square divided by n minus 1. And everything inside the square root, this is simply the variance. Because we have already subtracted our mean from measurement, and we have already divided by our total numbers of observation. Next thing we need to do is the something as saying standard deviation is what? Is the square root of variance. Standard deviation is simply what? The square root of 0.0317. In this case, the standard deviation is simply going to be 0.178 ppm, and this is it for the standard deviation. The last thing we are left with is what? A relative standard deviation, which is R. A relative standard deviation. For you to calculate your relative standard deviation, this is simply going to be what? You are going to multiply your standard deviation divided by your mean value. In this case, your standard deviation is given to be 0.178 divided by our mean, which is 12.15. Sorry, this is median. Mean is 12.05. If you point your RSD, if you point your RSD on your calculator, this is simply going to be, remember, we are going to multiply everything by 100%. If you point 0.178 by 12.05, this is simply going to give you 0.01477. If you multiply everything by 100, your RSD is simply going to be 1.48%. And this is it for this problem. In this case, we can finally conclude and say our median is 12.55 ppm, our mean is 12.05 ppm, our standard deviation is 0.178 ppm, and our RSD is 1.4%. So this is it for this problem. Thank you for watching.